All right, welcome to Fronius webinar on the energy management. My name is Sam. Some of you may have spoken to me over the phone. I work in the Fronius tech support departments. Alongside me, I'll have a Sebastian's.
Hey guys.
Who has been with the Fronius and working for Fronius as an application engineer. So we are going to do the presentations today on the energy management functions of Fronius products. So welcome to the Fronius webinar. We will do a questions sessions at the end of the webinar, and we'll try to answer all your questions at the end of the webinar. Okay, so I hope you're all able to hear us. I'm going to start this webinar. So with the 24 hours sun vision, we are aiming to offer our customers options for generating, storing, and distributing, as well as using the energy in an efficient and a cost-effective manner. Now, the use of a surplus energy for hot water preparations constitutes a really ideal solutions. So basically, storing the energy in the form of heat, and then use that store energy at a time of customer's own convenience. Fronius Ohmpilot, which performs this task precisely, is an ideal addition to the Fronius product portfolio, and also a step towards our 24-hour sun visions. So in this webinar, we would like to cover the couple of ways that we can do the energy management functions. The era of the generous feed-in tariff has ended, as everyone knows in the industry. So the focus has shifted, and it is important more than ever before to self-consume productions from a solar PV systems. The ideal solutions in that is how we can actually optimize the energy coming from your PV systems. If you would like to know what's the self-consumption rate or the self-consumption efficiency, as you can see here, there is an equations. So self-consumption rate is equal to energy self-consumed from your PV systems divided by energy from your PV productions or the storage, and that will give you the self-consumption rate from your PV systems. And we found that at the moment, this is the most cost-effective options when it comes to the energy management of your PV system. One might think that the options, battery option is the most cost-effective options at the moment, but as everybody knows that the batteries are still an emerging technologies, and it's also not a financially viable solutions at the moment. So what we believe is that how we can actually optimize the energy that's being produced from your PV system, and how you can actually switch on some of the consumers in the house when the PV system is working at its optimum power. So we are going to cover this couple of options and a couple of ways we can implement this. But if you would also like to know about your autonomy rate, this is the equations that you can use. And at the moment, as you can see here, the AR is equal to energy self-consumed, PV and storage divided by the energy total consumption will give us the autonomy rate. So how much self-sufficiency we can achieve from the storage systems. In this webinar, we are just going to cover the couple of ways that we can implement the energy management. of a PV system. As you all know that the Fronius inverters, they come with the Fronius Datamanager card inbuilt. It does have this orange connector plug where you can use the couple of pins to switch on a load at a specific time of the day or at a specific power level of the inverter. In order to do that, we will require an external relay. So as you can see that there is an external relay 12 volt DC, and that will require to be connected to a couple of pins of this orange connector plug. The other option is, of course, Fronius Ohmpilot. We'll cover that in details later on during the presentation. Okay. Fronius energy management functions that can be implemented using a Fronius Datamanager card inbuilt into the inverter. We recently launched a new software for the Fronius Datamanager card, and with that you can switch up to 4 devices. And I'll cover that in the next few slides on how to do all the settings for the 4 devices. And we believe, like I said before as well, this is the most cost-effective way to increase and optimize the self-consumption of a PV system. Please note here that the software required to implement the energy management function for 4 devices is 3.12.1 and then above. Okay, so below that software, we won't be able to switch on 4 loads or 4 devices using this energy management function on the Fronius Datamanager card. So that's just important information there. The wiring, as you can see here, that Fronius Datamanager card has this orange connector plug. We can use the pin number 0, pin number 1, pin number 2, pin number 3 to switch on the 4 loads. In this slide, we'll just show you how to connect only one load. As you can see, that this one is also has a Fronius smart meter installed at the side. So this red line here, that's the comms connections between the Fronius smart meter and the Fronius Datamanager card. Once you install the Fronius smart meter, you should also be able to view the consumptions of the household. And as you can see here, that this is a 12 volt DC relay, and that's connected to the pin number 0 and the negative of this orange connector plug. Okay, and as soon as this 12 volt relay gets energized by the Fronius Datamanager card, or the 12 volts coming from the Fronius Datamanager card, it will switch on this power consumer or a specific load. Many installers are using these functions of the Fronius Datamanager cards and switching on the loads like the hot water systems and pool pumps. These are the 2 most common applications that we have found is used for this function. Okay. Again, the same connections. If you wanted to switch on the other loads as well, you do the same connections as per this wiring diagram. But please note that you will require a 12 volt external DC relay. Okay, that's the important thing. That relay is not supplied by Fronius. You will require to buy the relay from an electrical wholesaler. In the next slides, I will cover how to configure all the digital outputs of the Fronius Datamanager card. Some of you may know, some of you may not know how to go to this interface page of the Datamanager card. There is a number of steps. One of the steps is activating the Wi-Fi access point on a Fronius inverter screen. So go to the setup menu on the Fronius inverter screen, activate the Fronius Wi-Fi access point, and connect your smart device such as tablet or a smartphone to the Fronius access point. And once the smart device is connected to the Fronius access point, you can type in this IP address of the inverter in a web browser, such as Safari and Google Chrome. This will open up this interface page of the Fronius Datamanager card, where you can configure all the settings. So to go to this IO mapping, you will require to click on the setting tab, which is in the bottom right corner. It will open up all these tabs on the left hand side of the page, and we go to the IO mapping tabs. Once you're in the tab, you will have to select the load management, click on this arrow, and it will open up all those 4 options for us. So if you're only using a pin number 0, just select pin number 0, and the other pins you can actually leave that by default. Okay, so only configure the required pins that we are using for the load management. Now the thresholds must be specified so that the inverter knows at what power level the output is to be activated and deactivated. Okay, so in order to set those thresholds, switch on thresholds and switch off thresholds, we go to the setting tabs called load management. Okay, so click on that setting tabs. Once you click on the setting tabs, you can see here that there are 3 options. One is disable, by power productions, and by power surplus. So you can also do the load management using just the by power productions. So you can set on the switch on limit and switch off limit. So for example, if there is no smart meter installed, then you can select this by power production options, and the load will switch on as soon as the inverter reaches to a certain power level. But what we have found that if you have a Fronius smart meter installed, then the smart meter will also give us the value of a surplus energy, or how much energy is being fed to the grid. Okay, so having a Fronius smart meter installed in the main switchboard will give us a very good information on when we can switch on the specific load. Okay, so by power surplus, you can click on select that options. We have a 2 threshold values there, feed-in and consumptions. The feed-in means what's the feed-in energy is being exported to the grid, and consumption means how much energy we are consumed from the grid. Now the hysteresis should also be specified whenever we set all those threshold values. So for example, if you have a pool pump rated at 1000 watts, we can select the on limit as feed-in 1200 watts, and we wanted to switch off that load as soon as it starts consuming energy from the grid. So we do select here 0 watts. So it will give us a hysteresis value of 200 watts. And basically, when we consider the hysteresis, we can actually stop switching off a load frequently whenever there is some changes occur at the feed-in point. Okay, so make sure that there is always a bit of a hysteresis value of 200 watts, and then we just wanted to stop switching of a load very frequently, because as you know that the frequent switching can also reduce the service life of that load. So make sure when you enter those limits, we need to be considering all the hysteresis value as well. Other important settings here is the minimum durations per on signal, which also needs to be specified so that to stop switching frequently in situations where the surplus energy or the solar radiations is changing constantly. And if you don't have this minimum durations per on signal set, then it will switch on and switch off quite a few times. And again, it may reduce the service life of your load. Okay, so consider all those values properly and enter those values properly. Maximum durations per day is basically how long you would like to have the loads on. So that's the number of minutes that you would like to switch on the loads for the day. And this is an accumulated minutes. So this is a total minutes per day. So for example, if it's on for 10 minutes or for 20 minutes, again on for 10 minutes, so it will accumulate all those minutes and keep the load on for the total number of minutes we have set here in this setting tab. Okay. Desired durations. This limit is set, and especially if you are switching on a hot water system, and on cloudy days when we don't have a surplus energy coming from our PV systems, we can also set the desired durations here per day. So on a cloudy day, you would still like to switch on the hot water system, then you can enter those number of minutes here, and also you can stop that functions by what time of the day. So if you want to stop the functions by the 6 p.m. or 7 p.m. and based on how long it will take you to heat the water in the hot water system. So you can say if it's a 240, it takes 4 hours to heat the water, then you can enter 240 minutes there. Okay. And as I mentioned before, that with the new software you can switch on up to 4 loads using the different pins of the Fronius Datamanager card. And the priority of those loads is always based on the power level that you have set in this load management settings. Okay, so the settings with the lowest power level will switch on first. Okay, now if you got two of those settings, load management 1 and load management 2 are set on the same power level, then it will take into considerations the very first one, and it will switch on that load management 1 and then load management 2. Okay, if you got the same switch on limit set for 2 loads, because that's important. We have got a couple of screenshots here showing how we can shift the load. Basically, this slide is showing how we have been able to shift some of the loads into the hours of where PV system is producing its maximum power. So as you can see in these first slides, that the own consumptions is actually not that high, or the self consumptions of a solar energy is not that high. But when you look at this, the second slide here, as you can, we've been able to shift some of the loads like the hot water systems into the hours when the PV system is performing at its peak power. So using that, we can actually self-consume most of the energy coming from a PV system, rather than feeding that energy back to the grid for low returns. Okay. So that was the option 1. You can use a 12-volt DC relay in combination with the Fronius Datamanager card inbuilt to the inverters to do the energy management functions. Option 2 that is the Fronius Ohmpilot, which also performs a very similar task. The hardware you would require for Fronius Ohmpilot is just that you need the Fronius Ohmpilot, of course. Our sales partners are selling the Fronius Ohmpilots, and they are available in the market at the moment. You will also require a Fronius smart meter here in order to implement the energy management functions with a Fronius Ohmpilot. So this is just a basic block diagrams on how to connect Fronius Ohmpilot, but my colleague Seb will cover that in details on how to connect Ohmpilots to the Fronius inverter. The basic principle that the Ohmpilot works on is called the pulse width modulations. So that's the principle it works on. So for example, if you connected this Ohmpilot or use the Ohmpilots in a single phase applications, it will provide this power in a continuously variable manner. So for example, whenever a Fronius smart meter detects that there is a 300 watts of surplus energy going back to the grid, instead of sending those 300 watts of surplus energy back to the grid, we would like to switch on this hot water systems. So it will start sending that 300 watts to the heating elements of the hot water system, and it does it in a continuously variable manner. One of the most important things here that we need to note is that it can only switch on the 3 kilowatt heating elements. So Fronius Ohmpilot for a single phase, it can only in a single phase applications. Please note that it can only switch on the heating elements rated at 3 kilowatt. Some of the hot water systems we found that comes with a 3.6 kilowatt heating elements, but the installers can then replace it with the one rated at 3 kilowatt. Unfortunately, if it's above 3 kilowatt, the Ohmpilot, Fronius Ohmpilot will not switch on that heating element, because it does the calibration whenever it's about to start, and as soon as it detects that it's actually drawing more current, more than 16 amps, then unfortunately it's not going to switch on that load. Okay. And in the three-phase applications, again, as soon as we get more than 3 kilowatt of surplus energy, it will switch on the second phase, and as soon as we get more than 6 kilowatt, it will switch on the third phase and continue to provide the elements on a phase one in a variable manner from 0 to 3 kilowatt. Okay, so that's the main principle that the Fronius Ohmpilot works on, as you can see here in this table. Now, how we can connect the Fronius Ohmpilot to the Fronius inverter? There are three ways we can connect this Ohmpilot to Fronius inverter. One of the way is using a RS485 connections. So when you open the front cover of the Ohmpilot, you will see there is a D positive, D negative, and negative terminals. And you just run those three wires from those Ohmpilot to the Datamanager card of the inverter. And if you have a Fronius smart meter installed at the site, you can also run the D positive, D negative, negative to the Ohmpilot, and Ohmpilot back to the Fronius Datamanager card inbuilt into the inverter. That's the one way of doing the connections between the Fronius Ohmpilot and inverter. The other option is you can connect this Ohmpilot to the same Wi-Fi modem using an Ethernet cable or a Wi-Fi connections to the modem. So Ohmpilot does have the Wi-Fi capability as well as all the LAN port, which you can use to connect to the same network as the Fronius inverter. So you don't really have to have a hardwire connections between the Fronius inverter's Datamanager card and the Fronius Ohmpilot. They can communicate with each other through this Wi-Fi modem, provided that these two devices are connected to the same network. Okay, what we've sometimes found that if the Ohmpilot is connected to the Wi-Fi modems via wireless connections, whenever there is a a communication loss to the modem from the Ohmpilot, it would affect the performance of the Ohmpilot. So we normally recommend having a hardwire connections or a LAN connections to the modem. Okay. Now this slide is when we have a different brand inverter installed at the site. So whenever there's a different brand inverter installed at the site, and if you would like to switch on a specific load based on the surplus energy coming from that different brand inverter, you will require to get a Fronius Datamanager box 2. You will also require Fronius Ohmpilot and also a Fronius smart meter. So these applications is mainly whenever you would like to switch on a hot water system based on the energy coming from a third-party inverter. Again, the connections are also very the same. This Datamanager card has got the inbuilt Wi-Fi capability. It's communicate to the modem via Wi-Fi or LAN connections, and this Ohmpilot will also have to communicate to the same Wi-Fi modem using LAN or Wi-Fi or wireless connection. Okay. Just the basic structure of the product. So when you open the front cover of the Fronius Ohmpilot, you will see these terminals inside the Ohmpilot. So you have this L1 coming in from the grid, you got L2 coming in from the grid, and L3 coming in for the grid for the 3-phase applications. But if it's a single phase applications, you just connect L1. And on the right hand side, you're seeing the output terminals. So the output of that L1 goes into the heating elements of the hot water system, which Sebastian will cover in details in the next few slides. Quickly go through again few software versions. It's very important to have the latest software versions with in the Fronius Datamanager card. If you have a Fronius SIMO hybrid, please also update the SIMO hybrid inverters as well with the latest software version in order to implement this function. And also you will require the Fronius smart meter based on the single phase or 3-phase applications. Okay. We'll now Sebastian will cover the next few slides, and we'll take you to on how to configure all the settings on the interface page of the Fronius Ohmpilot.
Thanks, Sam, for explaining those two different devices or options that you have with the Fronius inverters. So just as Sam explained, we have two options to do the energy management. So we have the actual inbuilt in the Datamanager card, there's the energy management function, but there's also this Ohmpilot. So you can see that it's two different ways. As Sam explained, the Datamanager card with the external relay, it is an on and off signal. And using the Ohmpilot, it is basically sending surplus of energy to a resistive load. So now what I'm going to cover is basically how to configure the Ohmpilot and how to also set up different parameters on the Ohmpilot. So when you have the box in front of you, you will see 3 LEDs. You can see that there's no screen there, and those LEDs will guide you and tell you what's happening to the system. So when you have a green LED, it means that the heating source is working, or maybe your Legionnaire function is working. If you have a blue LEDs on the Wi-Fi, it means that it is connected, so everything is good. And of course, if something is red, it means that there is an error on the inverter. So just looking at what's available, you have one button there, and depending on how many times you press the button, you will have different options. So one thing that we did listen to installers, they want something which is easily commissioned. So for example, as Sam explained before, if you have the Ohmpilot connected to the customer's network, there is a WPS function, which means you press the buttons once on the Ohmpilot and you press one button on the customer's modem, it will just sync straight away. So you don't need to go inside and select the customer network as you usually do with our Fronius inverter. If you still want to do it this way, you can press the WPS, the button twice, and then the access point will be available for 30 minutes. Or for example, we also have a safety measure. Let's say you don't have enough hot water and you want basically your hot water system to start and work at full power. You can press the button 3 times and it will work for 4 hours there. So that's basically the basics of the display there. So let's have a look at the interface. So when it's possible for you to connect your laptop or smart device to the Ohmpilot via its own Wi-Fi. So you press the button twice, the Wi-Fi access point will be available. And from there, you can see a lot of different settings there. So for example, on this page, this is the main interface of the Ohmpilot. You will see the status. So here there's an error 926. It will tell you how the system is performing, what's the temperature that you have also on the heating element, for example, and also the heating output there. So also you have the model number, the serial number of the Ohmpilot, the software version, and also if the system is connected to the customer network, you will see all the IP address, the MAC address of the device, and basically quite a lot of information there. So if, let's say, when you're connected directly to the Ohmpilot, if you want to look at the settings, what you need to do is open any web browser, type this IP address, which is shown here, 192.168.250.181. So this is just the IP address of the Ohmpilot there. So let's move then to the general settings. So what you will need to do as soon as you connect a heater or let's say a resistive load to the Ohmpilot, you need to tell it what's the size of this element. So you can do an automatic calibration, which it will see what's the power, or you can do a manual one where you will need to tell how much power it has, and then it will do the check. So that's the thing. If you do an automatic one and you have something which is more than, let's say on a single phase, more than 3 kilowatt, as Sam mentioned before, it will not start. So that's where it needs to be 3 kilowatt or less for a single phase and 9 kilowatt for 3-phase installation. So here you can see heater 1, heater 2, and also there's temperature sensor option. So I will just show you those settings. So if you have a temperature sensor, which is sold separately from the unit, you can say, okay, at this particular time, I want to make sure I have the minimum temperature at 40 degrees, for example. So from 6:30 to 7:30, I want to have a minimum temperature, and you can set 4 different times there. So this is just to make sure that you have hot water. There's also Legionella prevention that you can select, or also the maximum temperature that you want your hot water system to have, for example. Also, there's this heater 2, which I will explain later on with other single line diagrams. So some heaters or let's say hot water system, they have a buffer heater or a buffer component. And then from there, for example, if the main heater is hot enough, it will go to the buffer one, for example. So there's function like that, which is also available. So here you can see that there's also a second kind of safety measure. So remember, you have this boost function that you can press 3 times if you don't have hot water, or a more dynamic way of doing it. You say, okay, this time and this time, I want to make sure that it has this amount of temperature for the water. So there's safety features available for you guys. So here on the next interface, you can see the manual test. So basically you select manual, you say, okay, it is a single phase, and then you enter the power. From there, it will just do the test by itself, just to make sure that it is the actual power that you entered. And again, if you have a temperature sensor, you can say, okay, by this time, I want to make sure I have a minimum temperature of X amount. So that's just basic the features that you have with the Ohmpilot there. So the next one is via Wi-Fi. As explained before, you can have this WPS function, which makes your life easier. But let's say if you want to commission it yourself, you want to connect your smart device to the Ohmpilot and select a WLAN or LAN connection, then you type again this IP address 192.168.250.181 in a web browser. Make sure that the device is connected to the Ohmpilot. And then from there, you just go to the network tab and you will see all the Wi-Fi which is available. From there, again, if you have let's say a static IP address for this particular device, you can set that up. If you have a dynamic one, you just select that and you will get assigned one. From there, you just save and connect. If the LED turns blue, then it should be all good. Your system should be connected to the network. So this is one of the options. Also, let's say you change, we all hear about it. Some people change their modem, so that's where you can just have this WPS function or go into the settings and manually change the Wi-Fi, for example. So that's one of the options. So now what we're going to do is look at some application example. So how you connect and how you wire with a single phase heater element, for example. So here the PV dimmer is basically the Ohmpilot. You can see your main supply coming in at the bottom right, which is then connected directly to your element there, your resistive element there. From there, at the top, you will see the temperature sensor, which you can fit with some hot water system. From what we heard, it's quite straightforward. You just put it at the top, and you just need to make sure that it is connected properly. From there, on the one phase, as Sam mentioned before, it will have this PWM function where we're going to divert any excess of energy. So it's not an on and off signal as the energy management that we explained at the start. It's basically excess of 1 watt, excess of 5 watts, excess of 300 watts. It's just the excess of power which is sent directly to this heating element. So this is just the configuration for a single phase 3 kilowatt element. Let's now have a look at a 3-phase element, how it works. So again, we explained the principle at the start. So on the first phase, which is at the bottom here, you will see that that's where we do the ramping. So that's where we do 300 watts, 400 watts, 1 kilowatt, for example. As soon as we reach 3 kilowatt, we're gonna turn on the second phase, which basically then we're going to do the ramping again on the first phase, and the second phase it's full 3 kilowatt. So just an example, you hit 3 kilowatt, the second phase gets turned on, and then you still have excess of power. Then we play again with the first phase. So on the first phase, we have 1 kilowatt, 2 kilowatt, 3 kilowatt. As soon as we hit 3 kilowatt, the third phase turns on. So basically now you have 6 kilowatt on, and then we play again on the first phase. So every time the ramping up and down of excess of energy is done on the first phase. The second and third phase is just turning it on straight away. So that's how we do with a 3-phase element. We also have this question that comes up quite often. Some customers, as I mentioned, they have like a buffer segment of a hot water system. So again, what we do is this is a bit of a different setup where you have 2 elements of 3 kilowatt and a single phase. So what happened is, again, you need to wire your main supply to the Ohmpilot, but here internally, you will need to do some rewiring to those inputs and make sure that you do it as per this single line diagram. So what will happen is, again, we're going to prioritize here, for example, the HS1 max first. So that's where we're going to play. So, okay, we say, okay, 1 kilowatt excess, 2 kilowatt excess, 3 kilowatt excess. As soon as you reach the temperature required in the settings that you set up, we're going to turn the second HS2 on, which is basically the buffer one. So this is just a dry contact, which we just switch from one to the other one. So from HS1 to HS2. So there is different options available. So if you look into the manual, there's also other devices that you can work the Ohmpilot with, like with gas system, which has both gas and electrical, for example. So there is quite a lot of flexibility in the product. So that's just let's say the most common question that we have on our side here. The next one is basically energy profile. So we need to show customers and even installers our experience and what we can see when we, let's say, monitor people energy profile. So here you can just see a 5 kilowatt PV system on a, let's say, middle radiation, let's say cloudy summer day. And here, looking at the graph, they have around 7 kilowatt hour. So this is basically the light gray part of it, and the light gray is basically the PV earnings. So that's how much energy that they are sending to the grid. From there, you always have washing machines or dishwasher being turned on, or even electric cars, which is also a big topic, I think, coming here in Australia. So here you can see at around, let's say, 3 in the afternoon to 5, they are turning on their dishwasher and electric car, for example. So someone is back home, there's a high usage there. And also early in the morning, maybe, yeah, someone is taking a shower, or yeah, cleaning again from last night. So there's also quite a high, let's say, consumption at those particular time, where, let's say, the early one, the solar is not working there. So another example is, again, 5 kilowatt system. Now they are feeding about 20 kilowatt hour to the grid. So you can see that they have a lot of surplus energy, which is sent to the grid. Again, the same type of energy profiling, where you have your dishwasher, your normal consumption, so let's say lights, and then again your electric car in the afternoon, for example. So you can see how people basically use their power in general there. So what we did is we tried to look at the benefit of having an Ohmpilot or doing the energy management system, as Sam explained at the start. So what we have here, if you look at the cloudy day here, so this is before they install the Ohmpilot. So the customer, what they did is they installed a Fronius smart meter and a Fronius inverter. And you can see the blue part here is how much they're feeding into the grid. And the gray part is how much they're using directly from the PV. So after installation of the Ohmpilot, you can see that the profiling has changed. So we're not sending a lot of power to the grid at the moment. So, or after the installation, you can see that they are trying to use as much as they can. So this is where they increase the cell consumption. So they are trying to basically make the most of what you have installed. So they use directly the power from the PV there. So that's where they increase basically from, if it is a good day here, again, you can see that there is a perfect feed to the grid. And on the right hand side, after the installation of the Ohmpilot, you can see in the morning, they are feeding a lot to this Ohmpilot. The difference with this Ohmpilot and the energy management relay that Sam explained at the start is you can see how much energy is going to the Ohmpilot. If you have just the relay, the external relay there, then you will just see spike of consumption. So that's also a way of seeing what's happening to the customer, to see how the customer is using its power, and not saying, hey, maybe it is the light, maybe it is this, maybe it is that. So that's where I think it gives the customer better understanding how they are using their energy there. So here you will see that's the difference before and after installation of the Ohmpilot in July. So you can see that the self-consumption increased from 30% to 65% between June and July. So you can see that there is this increase, this significant increase there. So now we're going to look a bit on the technical data of the Ohmpilot. So that's the part number if you actually need to place the order, the maximum input current, which is basically for single phase and three phase, input voltage, that's quite straightforward. And this is the different output power. So that's where we tell you guys, make sure you're using a, when you're using a single phase element, it's not more than 3 kilowatt, and for three phase, not more than 9 kilowatt there. And the settings or what it can output, it is quite straightforward there. So this is just the technical data sheet. The inverter is rated IP54, so it is not waterproof. It is splash proof. If you're installing it outdoor, what we recommend, make sure, let's say it's there's a kind of a structure to protect it from direct, let's say direct contact with rain or something like that. So put just like I would say usually put it in garage or something like that, just to protect the Ohmpilot. Also, I wouldn't recommend to put it just in a box because always we need a flow of air just to be able to cool the whole Ohmpilot, of course. So that's where we say it's IP54, so splash proof, and not directly in the rain, for example. So that's basically the two options that we have, but also Fronius, as Sam mentioned at the start, achieving our goal, which is 24 hours of sun, means that we need to try to make the most of what we have here, to make sure that people try to use as much, let's say, renewable as they can. And what we really like, I think most of the people will agree, is we don't like to restrict people to, let's say, to only to our product. We want to make sure that a lot of people can use different devices, and that's why with this monitoring card, we want to make sure that there's third-party integration. So this is just some example here. So Loxon is kind of like a PLC controller, which can control different devices, and it's also user friendly. I've seen the latest version. It's just getting, let's say, block diagram, and you build your logic there. So it's like a ladder logic diagram. So it's quite straightforward to use. But there's also other platform that you can implement, which of course will require, let's say, a bit of programming. So there's IFTTT, there's Solar API, there's Modbus communication. And nowadays, I think Sam will agree with me, you can learn everything online, right? There's a lot of resources. So that's where we don't want to restrict people to use only, let's say, Fronius product. So that's where we open our Datamanager card, and you can do a lot of automation to make sure that you increase your self-consumption, for example. So I think that's quite a good idea if some people are interested. Did some myself, and also there's few colleagues around the world who did quite the same things. So I highly recommend, if someone is interested, play around with it. It's really cool. And yeah, for example, turning lights on and off, depending on how much you're producing, turning pool pump, turning aquarium pump. It's really crazy of looking at how many things you can do there. So that's basically it on our side. We're gonna maybe jump into the questions section now. So if you guys have any question, please just type that in the question section and we can answer. All right. There's already one question here. What is the difference between using an inverter card, which I think you mean using the energy management in the card, compared to the Ohmpilot?
I guess it's a very good question. There's a really good question, because what's the difference between the energy management functions using a Fronius Datamanager card and Fronius Ohmpilot? Now, the major difference between those two solutions, if you're doing the switching on the hot water system using the external relay, you will have to wait for the certain amount of power level. So for example, we showed you in the presentations that you will have to set the threshold for the activations of the relay. So basically, when you will have to wait until the full amount of energy is being fed to the grid. So for example, let's just say we set the 1200 feed in. So that means we'll have to wait until we get the 1200 watts of surplus energy from your PV systems. And below that, so if you're getting only 1000 watts from your PV system as a surplus energy, we cannot switch on that relay. Whereas with the Fronius Ohmpilots, what's the main advantage there or benefit is that as soon as we get a little bit energy, a little bit surplus energy, for example, 100 watts, 200 watts, 300 watts, we can switch on the heating element straight away. We don't really have to wait for a 1000 watt surplus or 1200 watt surplus. And that's the very main benefits of having a Fronius Ohmpilot installed for heating a water in the hot water system. I hope that answers your questions there, James. But what we found as well, that using the 12 volt DC relay in combination with the Fronius Datamanager card is probably the most cost effective way of doing it. But then there are some other drawbacks. One of them is that we have to wait for the full feed-in surplus energy before the relay can be clicked in. Okay.
So there's also another question: is there any conflict with the Fronius smart meter when it's being used to export limit? Example, access would be used and also limit 5 kilowatt export maintained. So from my understanding from the question here is you have an export limit and you're using energy management system. How does it affect it? So if you're doing, let's say, with the relay or the Ohmpilot, let's take the Ohmpilot for example. If you're doing a zero export, then it can create a bit of, let's say, not an issue, but a bit of a challenge there. So what happens if you have an Ohmpilot and you have a zero export? You will need to change the zero export to few watts, because we need to see a bit of power going to the grid. And as soon as we see a bit of power going to the grid, we're going to need to divert that. So that's where, after that, as soon as we start to divert power, the export limit will work as it should. For the let's say the external relay, it's basically kind of the same thing there. So if you have an external relay and you want to turn that on and it is zero export, then this is kind of a challenge there, because if you're saying, hey, when you're sending power 1200 watts to the grid, turn on, you will never send 1200 watts to the grid, because you have an export limit. So the export limit will always, let's say, take priority. In another case, if you have 5 kilowatt export limit and then you say, okay, turn on my relay when it's 1200 watts, then we're going to see this 1200 watt. It's a matter of seeing how much excess we have. But let's say you have a zero export system, you can say, okay, you can do it by power production, for example. And if you don't want to play with the export limit by power surplus, you can say, okay, if I have 300 watts, turn it on, for example. So there's ways of going around it. I would say it depends case by case. That's where you can contact myself or the tech support guys. But yeah, there's possibilities definitely there. Energy management would be better for in-flow slab heating, or can it be? So for this one, it really depends if you have a, so the question was, energy management would be better for in-flow slab heating, or can the Ohmpilot work also? So for your underfloor slab heating, it all depends if it is a resistive load or not. If it is not a resistive load, then it's not possible with the Ohmpilot. In both cases, let's say it is a resistive load, then it means that both will work if you're within the parameters there.
Once again, I think with the Ohmpilot, we really have to. It's important that the load that we're going to switch on is only 3 kilowatt. Okay, so if you're using it for different applications, make sure it's actually rated at 3 kilowatt. Otherwise, it will not switch on.
Yeah, okay, so it's the most important thing. 3 kilowatt for single phase, 9 kilowatt for three phase. But yeah, in those situations, it really depends which way you want. For example, if you have quite a big flow heating, then I would say sometimes it's going to be good to use an Ohmpilot, because a customer can really see what's going to that. That's, I think, the big benefit of using an Ohmpilot. If you want to use the energy management, you can do the same thing. And also, if you want to use the energy management, there's other options where you can monitor this particular load, for example. So there's like features inside with our Datamanager card to be able to do those. Well, this is where I think it goes to the next level. That's where you get in touch with us and we can explain different options.
Yeah,
there.
I guess we have had a few installers who implemented this energy management functions for the flow slab heating using that 12-volt DC relay, and it's been working fine. But with the new software in the Fronius Datamanager card, like we covered in the presentations, that you can switch on up to 4 loads, 4 resistive loads, okay, because the resistive load can handle the frequent switching, whereas if you have the inductive or capacitive loads, if you would try to switch on the load frequently, it would cause an issue with the service life or with the load. So that's why we always recommend that this is used for resistive loads only. Okay.
And then you also have those safety features saying, for example, you don't want it to turn on and off often. You can set that up, for example, on the Datamanager card.
Quick questions was asked about the copy of the presentations. We will send a file, the presentation file, to all the participants in the next few days. So you will receive an email with the copy of the presentation.
Yeah. There's another question. Can you parallel up Ohmpilot in a system for multiple loads? On our side, we say that it's not possible, but I think there's a company who tried to do something like that. I would say get in touch with us. I need to double check that. But from what I know from the last update is you can't parallel multiple Ohmpilots. But again, maybe there's ways around that. So that's where I would recommend if you can just get in touch with myself or Sam there, so that I can find this information. All right, guys.
We'll still wait for another 5 minutes. We're still going to be another 5 minutes. 5 minutes. So if you have any questions, thank you, Chris, for your feedback there. Thank you, Michael. Appreciate your feedback there.
We also recommend you guys, if you want to come and see us at All Energy this year, highly recommend. There will be a few other guys there. So yeah, for sure, please. Got a question. Is it possible to switch a heat pump with the relay? Yeah, you can do that with an external relay. For the heat pump, I'm not the pump expert, but I know that they don't like to be turned on and off quite frequently. So in the settings where Sam showed you, you need to make sure that per on signal, so every time you have, let's say 5,000, as an example, 1,000 watt excess, you want this signal to be on for, I don't know, 15 minutes, for example. So just to make sure that it doesn't turn on and off frequently. Yeah, but so it is possible.
It is possible to switch on a heat pump because I think it's not a pure resistive load. So we have to be a bit careful in terms of how many times we can switch on. It may not like frequent switching, but we can set those settings in the interface page of the Datamanager card, where we had one of the setting that says minimum durations per on signal. So this is where you can actually do minimum duration per on signals to 5 minutes or 10 minutes, depending on the type of the load.
Do you have my contact, Chris, or do you have anyone contact at Fronius?
Or maybe Chris, thanks for that update there. Can you please provide us with your contact number so we can get in touch with you and give you the correct information there as well? Chris Ryan.
Yeah. That's a bit funny. We have someone on side here. So there's a question. There's a smart meter commissioning, and it's asking for a username. Is it admin? It should be service, Steven.
So if you're going to the technician visit, it's always this username is always a service in lowercase. Just again quickly about this 12-volt DC relays that you can source from an electrical wholesaler. Please make sure that this relay, the external relay that you require, in combination with the Fronius Datamanager card, that needs to be energized on a 12-volt DC. Okay, so that relay basically energized on 12-volt DC. So just thought I'd mention that point there.
All right, I think that's pretty much it. Thanks, guys, for staying and to get to know a bit about our product. Hopefully, we're going to see everyone at All Energy.
Thank you so much for your attentions and attending this webinar. Any questions, you can always contact our technical support hotline or send us an email, and we'll answer your query. So we'll just wrap it up. Thank you so much, everyone.